Back. This is Mr. Hassan's Maths channel, and I'm now going to be answering question number 6, which is the final question from this January 2023 Statistics S1 paper from Pearson's Edexcel. International A-level paper. It says a research student is investigating the maximum weight Y grams of sugar that will dissolve in 100 grams of water at various temperatures, x degrees Celsius, where x is between 10 and 80. The research student calculated the regression line of y on x and found it to be y equals 151.2 plus 2.72x. Given interpretation of the gradient of the regression line. So the gradient of the regression line is 2.72. Okay, that's the gradient. Okay, y equals, because mx plus c equals a plus bx. It's the value of b in terms of regression lines. That is the gradient. And that tells us the change in y with respect to x. This is y, this is x. So y, as I told us, is the weight of sugar, okay, and x is the temperature. So you can say that as the temperature increases by 1 degree Celsius, as the temperature increases by 1 degrees Celsius, then 2.7, there will be an increase. The increase in the amount of sugar dissolved, the amount of sugar that dissolves is 2.72 grams. Okay, so when the temperature increases by 1 degree Celsius, the increase in the amount of sugar amount of sugar dissolved is, you can say dissolved in 100 grams of water. The amount of sugar, let me just put that as one sentence properly. Okay, so the increase in the amount of sugar dissolved in 100 grams of water is 2.72 grams. Okay, so basically the change in y over the change in x, that's the gradient, right? So the temperature increases by 1 degree Celsius, the amount of sugar dissolved will increase by 2.72 grams. Okay, so that's an interpretation of the gradient of the regression lines. When it says give an interpretation of the gradient, it doesn't mean just write down 2.72. Doesn't mean just write down the value. Interpret it in layman's terms. Interpret it in the context of the question. Okay, so don't, you have to mention about the temperature increasing and the amount of sugar increasing by that amount for each 1 degree Celsius rise of the temperature. Okay, then part B says use the regression line to estimate the maximum weight of sugar that will dissolve in 100 grams of water when the temperature is 90 degrees Celsius. So basically you want to find what happens when x is equal to 90 degrees Celsius. So y will be 151.2 plus 2.72 times 90. So we can just stick that in a calculator. So you have 151.2 plus 2.72 multiplied by 90. That gives me 396 grams. Okay, now that's part B. Then part C says comment on the reliability of your estimate, giving a reason for your answer. Well, the range of temperatures that we had in our data was between 10 and 80. Okay, so you can say the range of x in the data is between 10 and 80. So x equals 90 is out of the range. is out of the range. So therefore, it would be called extrapolation. Extrapolation means you're using data outside of the range to make estimates from our data. So will be, okay, unreliable. It's going to be unreliable as it's outside of the range of our data. If it's within 10 to 80 that we're using to estimate, that's fine. But you go outside of the range of the data, it's unreliable. Okay, so we have extrapolation here. So we should mention something about our limit being from 10 to 80. 90 is outside of the range. Therefore, we have extrapolation and it is unreliable. Something like that for part C. Okay, now we're going to go through question 6, part D. It says, using the regression line of y on x and the following summary statistics, show that the product moment correlation coefficient for these data is 0.988 to 3 decimal places. Okay, so we've got to use this data given and also the regression line, both things, to try to work out the value of the product moment correlation coefficient. So first of all, we've got to think out, what is this product moment correlation coefficient? Well, this is, if you look in your formula book, you will see it mentioned. So go back to the formula book, and we'll see that it says the product moment correlation coefficient is, and they give us all these formulas. So I'm just going to take this and copy it and put it exactly where we need it in the other page, so we can. So let's copy all of. Oops, need to copy all of it. Do that again. Okay, so we got this information here, which I'm going to paste on that page that we were on. Get a bit smaller. Okay, so that's the product moment correlation coefficient. It's given the symbol R, and R is equal to basically this. This is what we can summarize it as. R is equal to this thing called SXY over the square root of SXX times SYY. Now, what are those things? Okay, now you can see that you'll notice that this is, oops, supposed to be in blue. This here is SXY. Okay, and then the square root of this is SXY, and this is SXX, and this is SYY. Right, so that's what we can see, SXY, sorry, over SXX times SYY under the square root multiplied together. All right, so now, if I can find what these three things are, I can find what R is. I can show that R is equal to 0.988. So I need to find what these things are. Now, they gave us some things in the summary. They've got the sum of Y. Okay, so we've got this. We know what this is. I'll put that in a different, I'll highlight them under a different color, the things that we got. Right, so we have, for example, we have the sum of Y. Okay, that's what we have. We have the sum of Y squared. Right, we have N. Okay, so I can find SYY directly. We've got the sum of X squared, which is this. All right, so the things that we don't have are SXY. We don't have the sum of X times Y. We don't have the sum of X. We don't have the sum of Y. Yeah, we do have the sum of Y, sorry. I'm supposed to be highlighting the things that we don't have, that we do have. So we have the, so we don't have these things that are not highlighted. So we need to find X, the sum of XY, the sum of X, and the sum of X squared. Those are things that we need to find. Basically the sum of X. We got the sum of X squared, as I said. So the sum of X we need to find, and we need to find SXY somehow. Right, so let's figure out how we can continue. So first of all, let's find what SYY is. That's one we can find straight away. SYY, we have everything we need, which is the sum of Y squared, which is 851,093, minus the sum of Y then squared, which is this. This is the sum of all the Y values and then squared. So 3,119 squared, and that's divided by N, which is 12. Now that's going to give us SYY. So you have 851,093 minus 3,119 squared divided by 12. Oops, divided by 12, sorry. So that's SXY, 851,093. Okay, that's sum of y squared minus the sum of y, which is 3,119 squared divided by 12. Okay, so that gives us 40,412.91667. So I'll write this as it is, 40,412, 40,412.91667. 1667. I'll just write the exact value. That's SYY. So I found SYY. That's found now. Now I got to find SXY and SXX. Now, to find SXX, right? To find SXX, I need to know the sum of X. I need to know the sum of X, right? That's what I need to know. Now, how do I find the sum of X? I don't know, the data values at all. All I have is what they told us, the equation of the regression line. So I'll bring that down. Okay, and I have that summary data. So from the summary data here, there's no way for me to find the sum of X. Okay, the sum of all the X values. This is the sum of all the X values added together and then squared and then added together. So I can't just find the square root of this. That's not what it is. This is not the sum of X, all of it squared. This is the sum of the sum of the squares of each X value separately. So I can't just square root that, for example, to find the sum of X. So I've got to find another way of doing it. Now, there's no way from the summary data, so obviously it must be from the regression line of y and x that we can find what we need. Okay, because it says use the regression line and the following summary statistics. So now let's go back to the formula book and see what it says about the regression line. If we go back to the formula book, it says the regression coefficient of y and x is such and such, and the least squares regression line of y and x is such and such. So I'm going to take this information here, and I'm going to hopefully use it to find what we need. Oops, just get it a bit more. I need more of that. Okay, I think I need to take all of this, take it back to our page. Okay, and I'm going to use it over here. So now we're going to use, hopefully, this to find what we need. Okay, now, so it says the regression line coefficient of y on x is b equals sxy over xxx. The least squares regression line of y and x is y equals a plus bx. So y equals a plus bx. So we can say from here, as we deduced before, a is 151.2 and b is 2.72, right? Now, I can see that I can use this to find sxy, because I know what sxx is, I know what b is, so I can find the thing that I was looking for, sxy, using the fact I have those two. So I can do that straight away. So I can say, okay, I know that b is equal to sxy over sxx, and therefore I can say b is 2.72, and that's sxy over, and we found we found syy, sorry. Okay, so actually, we need to find sxx first, right? So that if we found sxx, we can find xy directly without having to find these other things here. Okay, that's one thing. So how do I find sxx? Again, we have to go back to finding the sum of x. Okay, now, what they told us here is something else. Okay, let me change the color. They've told us the value of a is equal to the mean of y. Now, the mean of y is the sum of all the y terms divided by n, minus b times the mean of x. And the mean of x is basically the sum of all the x terms divided by n. So I know n, okay, and I know I can work out what the sum of x is because I have all these information. I know the mean of y. I can work out the mean of y because I have all the sum of the y terms. So I can work out the mean of y. It's going to be this divided by 12. So I can work out what this is. All right. Okay, so I can work out what this is. So if I know what this is, I know what A is, I know what B is, I can work out the mean of x. And if I know the mean of x, I can work out what the sum of x is. So using this formula, A equals the mean of y minus B times the mean of x, okay, I can replace the A with 151.2. And that's equal to y, the mean of y, which is the sum of y, which is 3,119 divided by 12. That's the sum of y divided by 12. That's the mean of y minus b times, now b is 2.72, times the mean of x. Okay, so I can work out what the mean of x is. All right, so if I basically, if I do this, if I subtract these, if I do 151.2, in fact, what I can do is, 151.2 minus, in fact, what I'll do, I'll write this as this to make your life easier. This will make my calculation a bit easier. I'll call this the mean of x as what I'm looking for, which is the sum of x divided by n, which is 12. So what I can do now is I can multiply both sides by 12, make it a bit easier. So I'll have 12 times 151.2 equals 12 times this, which is 3,119, minus 12 times this, which is 2.72 times the mean of x. Okay, so if I have 12 times 151.2, in fact, I'll have to do it the other way around. What I'll do is I will add this to both sides, and I'll subtract this from both sides. So I'll end up with 2.72 times the sum of x is equal to 3,119 minus 12 times 151.2. Okay, and that I have to divide, so then I'll divide that by 2.72. So the sum of x equals 3,119 minus 12 times 151.2 divided by 2.72. So I'll have here 3,000. I'm going to store this as A in case I need it again. But I have here now 3,119 minus 12 times 151.2 divided by 2.72. Now that gives us 479.632. 479.632. So that's the sum of x. So I found the sum of x. Okay. And now if I find the sum of x, therefore I can find what SXX is. SXX, as we can see from here, is this. It's the sum of x squared, which we have, which is 24,500, minus the sum of x, which we just found, over 12. That's going to be just SXX. So we're going to have 24,500. So you have 24,500 minus 479.632. I'll put the exact value in. That's squared divided by 12. Okay, so I'm going to do this. I'll do 24,500 minus my answer squared divided by 12. That gives me 5,329.4. 5,329.4. And I will store this as B. Okay, so now I can say R is equal to, now I can use all these values. So R is equal to SXY, R is equal to, as we see here, SXY over the square root of SXX times SYY. So R is equal to the SXY over the square root of SXY double x times s double y. So sxy, we calculated it. Oh, now we can calculate sxy, right? Because I know what sxx is. So now we've got to do that. So that's sxx. Therefore, we can say sxy is going to be 2.72 times sxx. So it's going to be 2.72 times this value, 5,329.4. All right, so we've got to find what that is first. So I can actually put this in here directly in this way. So I have my calculator, right? So what I can do is this was my sxx, so I can multiply this by 2.72. So I'll do this. I'll do the answer we got multiplied by 2.72 over the square root of sx x, which we just found, okay, which was the answer that we had last, multiplied by, and we've got to have syy, and syy was, we found earlier, it was that 40,000. So times, and I'm going to recall that 40,000, recall, that was A. So I'll put that as A. So recall A. All right, and that should give us an answer. Hopefully, when I press equals, the answer should come out 0.988 to 3 decimal places. So let's hope for the best here. So equals, yes, it worked out fine. So that gives us, well, the best thing for us to do is write down actually the values that we said. So I'll put 2.72 times 5329.4 dot 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 over the square root of sxx, which was 5,329.4, multiplied by syy, which was 40,412.9. 40,412.9. Now I've used the kind of exact values, so I got R equals, and what came out was 0.987752. 0.987752. So we got to show that it rounds to 3 decimal places as 0.8988, and we can see that that is 0.988 to 3 decimal places. And we have answered that question. That's part D. Now that was a bit of an involved question actually. They're not normally this involved. All right, I guess it's the last question of the paper. But you couldn't just use the summary data, and the clue for that was use a regression line on y and x and the following summary statistics. So the summary statistics only took us so far, only really helped us to find syy. And to find sxx and xxy, we had to use the regression line, and we had to understand where the A and the B come from and how to deal with it. So all of this stuff can be found by using the formula book, by looking at these. You don't have to memorize any of this, but you should know and understand how to do it, right? So that was a bit of an involved question. It took a bit of time, but we got there in the end. And it's very satisfying when you see after all that hard work that you get the right answer at the end. If it come out as wrong, you know that you made some silly mistake somewhere, and you've got to go back and check what's happening. So that's always a good feeling, especially in an exam when you don't have much time, that you get the right answer. And that's one of the reasons why they give you, sometimes show that equals this, to make you rest assured that you've done the right thing. All right, now for the last part of this question, which is part E. Where is it? It's over here. Okay. It says, the research student supervisor plotted the original data on a scatter diagram shown on page 23, which is this page here. With reference to both the scatter diagram and the correlation coefficient, which was 0.988, discuss the suitability of a linear regression model to describe the relationship between x and y. Now, what does that mean? A linear regression model, they're saying, basically, how suitable is it for us to use a line of best fit, which is a straight line, to help us to predict values within this data. Okay, how suitable is a line of best fit, which is a straight line, for this? And we can see that from the shape of the graph, from the shape of the dots, they're quite close to a straight line, and the correlation coefficient being very close to +1, okay, that a linear regression model would be very suitable, okay, because the value of R is close to 1, and the the points are very close to a straight line. Okay, so we can just mention it's only two marks. We can say as the value of r is close to 1, even if it was close to -1, it would be like a negative correlation, but it would be show that they're close to a straight line. As the value of r is close to 1, okay, and the scatter diagram shows the points, okay, close to a straight line. They're not like spread out everywhere. They're quite close to a straight line, okay? Therefore, we can say a linear is a straight line regression model is very suitable. It's highly suitable. Okay, it's highly suitable to describe the relationship between x and y. Okay, so something like that is what we need to write there, and that concludes this question. That's a nice little, you know, ending part, I guess. Very easy. Okay, so there we have the answer to this question, which is question number 6, and the final question on this paper, okay, of this January 2023 paper, S1. Other questions from this paper can be found in the playlist that will appear in this region over here at the end of the video. Other questions from this topic of regression and correlation can be found in the playlist that the link will be over here at the end of the video. You can subscribe to my channel by clicking on the link here, and you can watch the video that will appear in this region to help you to navigate through my channel and find things that might be useful to you. Thank you for watching, and see you soon.